Hello and welcome back to my channel once again. In today's tutorial we shall be looking at the linear variable coefficient of the ordinary differential equation. In the previous video we have looked at the introduction to ordinary differential equation. So in this one we shall be looking at the linear variable coefficient. Now when we talked about the variable coefficient and then a constant coefficient, when the value of a, that is when this a depends on t, then we refer to it as a variable coefficient. But if it does not depend on t, then it's a constant coefficient. So without much ado, let's try to prove the general formula for the variable coefficient. So it is saying that the variable coefficient is of the form y prime equal to a of ty plus b of t, and the general form that we are to prove is y phi equal to c of e exponent at plus e exponent at all integral of e exponent negative at b of t, where c belongs to all real numbers. But it is saying that a here is equal to the integral of at, and so we want to prove it. The general form of differential equation we know is of the form y prime equal to a y plus b. So this is what we are going to use to prove this particular formula. But a here and the b, a and b here, are functions of t. It means that a depends on t and b also depend on t, and which makes it what? A variable coefficient. So without much ado, let's continue. So I group like them. So y prime, sending a y across, I get a y equal to b. Now multiply through by u. So u y prime a u y equal to b u. Now let negative a u to be equal to u prime. Say this is star. Now we substitute this back into the previous equation. So I now have u y prime plus u prime y equal to b u. So if this is it, I can factorize this as y uy all prime equal to b u. When I differentiate uy using the differentiation by parts, that is, I hold y and differentiate the u, and then I hold the u and differentiate the y, I'll get back this equation. Okay, so to continue from, let's find u is equal to e exponent integral of negative a dt. This has been explained in my previous video, but then let's just take the time to go through it. So from star, where we looked at, from this one we can find the u. So we say that negative au is equal to u prime, right? So divide through by u, I have u prime over u equal to negative a. Then take lim of this, so you get that is equal to a. Now lim of u all prime, when I differentiate it, I get back this equation or this particular thing. So you differentiate u and divide it by u. Okay, so I get back this. That's the property of the lim, differential of lim. Now that I have done this, I want to take integral on both sides. So take integral on u respect to the t, which implies that that is the integral sign, will go with the differential sign here, leaving this. Because a is a variable coefficient, it depends on t, we cannot integrate it just like that. Okay, so I will leave it as integral of a dt, and so you further take e on both sides. So I have lim of u is equal to e integral of a t. Okay, now u is equal to e exponent integral of a dt. But then we know that a is equal to integral of a dt. So therefore u will be equal to e exponent a. Okay, u will be equal to e exponent a. Now with that concept we can carry on and hold. But before I forget, this is negative, so the negative affects this, the negative affects this, the negative is here. Sorry for the inconvenience. So here is negative, it means that I'll have negative a here. Okay, now we go to substitute this back into equation 1. We substitute it back into equation 1, which was u y all prime equal to b u. Now that we have gotten our u, we substitute it inside this particular equation. So I now have e exponent negative a y all prime is equal to b e exponent negative a. Now take the integral of the right hand side and differentiate again. So I will take the integral of this side and I'll differentiate at the same time. Okay, so say that e exponent this is equal to b e exponent negative a dt, taking integral on all and then differentiating at the same time. Now let me group like I'm sending whatever is in the right hand side to the left hand side. I have e is with negative a all y prime minus integral of b a dt all prime is equal to 0. E is with negative a y. I can factorize everything as this. All prime, and this is what we call the total derivative. Total derivative. I can go further to say that, so if this is a total derivative, I can let q of ty to be equal to what is in the bracket, that's negative a all y minus integral of b e exponent a dt, and this is what we call the potential function. Potential function. Now we know that since q is equal to the potential function, then q prime will be equal to 0. Now take integral on both sides with respect to t. So I have integral of this with respect to t, integral of this with respect to t, and therefore I have this to be equal to c. We come back and substitute the potential function inside, which is a exponent negative a y minus integral of b exponent negative e exponent negative a dt is equal to c. We are looking for y. We want to make y the subject. Therefore, I maintain e exponent negative ay, then equal to c. Take this across the equal sign. I'll have plus integral of b e exponent negative a all over dt. Now with this, divide through by e exponent negative a, divide here by e exponent negative a, and divide it through by e exponent negative a. And I'll have y to equal to, because this is going to cancel this, and then I'll have c e exponent a plus 1 over e exponent negative a all integral of b exponent e negative a dt. Furthermore, we can have y to be equal to c exponent a. I can rewrite this one too also as e exponent positive a, because if I have 1 over 2, it can be written as 2 exponent negative 1. It's the same. So if I have e exponent negative 1 divided by, and 1 is divided by it, then I can rewrite it as e exponent positive a, and all is still multiplying by b e exponent negative a dt. Okay, so with this, our formula is being proved, but we say that the function is with respect to t. So therefore, I can rewrite it as y of t to be equal to c exponent a of t plus e exponent a of t all integral of b e exponent a of t dt, and hence your formula is being proved. So this is the proof to what we are looking for. Alright, so we shall take one example and look at how we can use this particular formula to digest it, or even taking it from the beginning to this point. So example 1. So we say that find y if y prime is equal to y 2 minus 2 sine of t. So we find the solution using the same procedure we used to prove this formula. We can be able to solve this question. So we have y prime equal to y minus 2 sine t. Group like terms. This is equal to minus 2 sine of t. Multiply through by u. So have uy prime minus uy is equal to negative 2u sine t. Now let u prime to be equal to negative u over here, and substitute back into the previous step. So we have y prime plus, so negative gives you positive, so we have plus u prime y. This is going to be equal to negative 2 u sine t. Now that we have done this, I can also factorize it again, just like the other one. So we have this to be equal to negative 2 u sine t. So say this is equation 1. It's equation 1. Now from here, we can continue to find u. So finding u, we say that u is equal to the integral of, mostly is the e exponent, the integral of the coefficient of the y here, uy, the coefficient there. So the coefficient here is negative 1. So the integral of negative 1. So we have negative 1 dt. Okay. So any of them, usually that when we are proving, is always the coefficient of u, y that is here, that we pick, and integrate with it. So in the example, I've explained how we get the u. So let's continue with this. And this is equal to integral of negative 1 dt is negative e exponent negative dt, negative t. With this, we go and substitute back inside the equation 1. We put it inside what? Equation 1. And in substituting, equation 1 is here. So my u, which is e exponent negative t y all prime, is equal to negative 2 e exponent negative t sine t. Alright, we'll further go ahead. Now we integrate the right hand side and differentiate as well. So in doing that, we can only do this by using the integration by parts. We can do that by using the integration by part. So taking the right hand side, taking this side alone, I want to integrate it, and then we can differentiate it at the same time. So taking integral of negative 2 e exponent negative t sine of t t. So we integrate it. Now using integration by parts, the formula is integral of u v is equal to u v minus v du. So it is your choice to know which one you make as your u and which one you make as your v. But make sure the one that you are making as your v should be easy to integrate. Okay, should be easy to integrate. So now let u to be equal to sine t, implying that du will be equal to cos t. Now let dv to also be equal to negative 2 e exponent negative t, implying that v is equal to integral of this, and v is now equal to 2 e exponent negative t. That is, in the differential of integral of let's say you have e exponent negative t, you differentiate the top and divide it. So when I differentiate negative t, I get negative 1, so negative 1. And remember, we already have negative 2 here, so the negative will cancel this negative, and that's how come we have the positive 2 here, right? Now we go and substitute this inside the formula. I now take integral of u, and u we said is sine t, and the v is negative 2 e exponent this, which is equal to v, and v is that u is sine t minus integral of v, that is 2, and the u is cos v. Now we have done the first differential, but yet still we can't quickly integrate this side. So therefore we take only that side and deal with it. We take only this side and deal with it, and now substitute inside the first equation. So let's say this is equation 1. So we solve this and bring it back and substitute inside equation 1. Okay, so from this, let u to be equal to cos t, implying that the u is equal to negative sine t, the v to be equal to 2 e exponent negative t, implying that v is equal to the integral of this, and then v is finally equal to negative 2 e exponent t. Now again, we substitute inside the formula, that formula which says u dv is equal to u v minus v du. So here we know u to be cost, and then v to be equal to negative 2. So I have negative 2 tu, which is cost t, to be equal to u, which is cost, and v, which is minus 2, all minus integral of v, negative 2 exponent t, then du, which is negative sine v. So you just have to take your time with the signs so that you don't make mistake. Now we go ahead. This gives me, I want to rewrite this as negative 2 e exponent t cos t minus integral of negative 2 t sine t. So let's say this becomes positive. Alright, so we continue substituting this. So let's say this is question 2. We want to substitute this inside the first equation. And then for the first equation, I'll have negative 2 e exponent t sine of that t equal to 2 exponent this sine of t minus, now we can now substitute everything of this inside in the place of integral of 2e exponent negative t cos t dt. That's what we have found, and that's what we have this. So therefore we substitute it inside here. So I write it as negative 2 e exponent t cos t minus integral of 2 exponent negative t sine t dt. Okay, and furthermore this is equal to, so I expand the bracket. So if I'm expanding the bracket, this negative goes inside. I have positive 2 cos t. I have positive integral of 2e exponent t sine t dt. Okay, so taking this one, that is this side, across the equal sign to meet what is on the other side, we will have negative, let me write it before we add. So negative 2e exponent t, because it's positive over there, so coming to the other side will be negative, plus another negative integral of 2e exponent that sine of t dt, and this is all equal to 2e exponent negative t sine t plus 2 exponent negative t cos of t. Alright, so when I sum this to, I have negative 2 integral of 2 in the bracket, this sine of t dt, and this is going to be equal to negative t sine of t plus 2e exponent negative t cos of t. Now you can see the 2 is common in all of them, so I divide through by the 2. Dividing through by 2, I have integral of 2 exponent negative t sine of t dt to be equal to e exponent t sine t plus e exponent negative t cos t. This is what we were trying to integrate and differentiate. So now we recall that this is what we're looking for: u all prime to be equal to negative 2u sine t. Remember, but we found this to be u to be e exponent negative t, and so this is equal to that, and so we were trying to integrate this and then we differentiate it, and this is what we have found over here. So you just substitute inside and you are good to go. So note there's a negative here, it doesn't affect that one. Okay, so now I have e exponent this all prime to be equal to e t, we are substituting plus e exponent negative t cos of t. Finally, we still differentiate the same thing, and this is going to be equal to, I pick it across the equal sign, then I have e exponent t all y prime minus e exponent negative t sine of t minus e exponent negative t as plus cos of t all prime. This is equal to 0. This can be written as e, factorizing the whole thing, e sine t minus e exponent t cos t all prime is equal to 0. You will see that is a total derivative. Now we can say let q to be equal to e exponent t y all y minus this minus, and if that's the case, q prime will be equal to 0, taking integral on both sides. So we're taking integral on this side, taking integral on this side with respect to t. It means that q will be equal to c, and which implies that e exponent t multiply y e exponent negative t sine t minus e exponent negative t cos t will be equal to c. Because I'm looking for y, I maintain this and send the rest across the equal sign. So e exponent t all multiplied by y equal to c plus e exponent t sine of t plus e exponent negative t cos of t. So wonderful. So divide through by what? E exponent negative t. When I'm dividing through by e exponent negative t, I have y to be equal to c over e exponent negative t plus e exponent negative t sine t on e exponent negative t plus e is my negative t